cover not. So what I'm going to do real quick, if I have A implies not A. Now, if you think about it, if A implies not A, that means these two cancel each other out. So A implies A. That's the way we read it. However, through logic, we have to change it up a little bit. So this is our goal with the box proof. A implies not A. So what we have to do, draw a box, put A at the top of it. So A, and what's at the bottom? You have to have not A. Now this doesn't really make sense logically, because this contradicts each other. So what do we have here? We have not A, and we state that this is a contradiction. Now this is actually the completed box proof. You have 1, 2, 3, 4, 5 lines in it. So what you have at the top is you have one great big assumption. You assume A. You also assume not A. But what's the problem here? You have a contradiction, because in order for this to work, for this to be the outcome, you have to have this contradiction there. So you have a not elimination. Then you have a, sorry, camera shaking. Then you have a introduction and another introduction. So this is a not introduction and this is an implication introduction. So if we work from this, so this is from lines 4 and 1. Then you have the introduction based off line 2 and I believe line 3. I'll come back to that. Then you have an elimination. I'll come back to that. And these assumptions work normally. Just 1 second. Yeah, just double check my notes. So this is an elimination from line 1 and 2 because you're eliminating the contradiction there to produce this. So I'll just do it 1 and 2. And this is an introduction from lines 2 and 3. So you're introducing a contradiction here. So the not. So you have 2 and 3 there. And then based off line 4 and 1, you have that. So that's pretty much how you do a basic not. Honestly, just play around with a few examples and you'll get it. So essentially, if I had A implies not A, I have essentially the same thing, but it would have an extra box inside and the number of nots would have to adjust accordingly. So I can just do this quickly actually. A at the top, and I'll add more space. So A implies not A. So big old box at the top. A, the bottom here is you have not A. Then you got a contradiction, big old contradiction there. So you get not A. Then you got another box, another contradiction, not A, another box, another contradiction, not A. So essentially you assume this, you assume this, you have a bunch of introduction, and you do essentially the same thing. And then this is an elim, this is an elim, this is an elim, it's an introduction, and this is an introduction. So then that makes these assumptions. So I have 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. Okay, 8 and 9. I have 9 lines. I make an assumption. I do an elimination base off of line 3, I believe. Elimination line 3 and 4. Let me just double check it. So doing I just studied this, so I'm still getting used to it. So elimination based of line 1 and 2. So this would be this would be assumption, not 1 and 2, but this and that. So that'd be 3 and 4. Then that would be 3 and 2. So no, then this would be 6 and yep, line 6 and 2. Then I have another elimination based off line 7 and 1. 7 and 1. So then this introduction comes from line 2 and I believe it's 2 and 7. 2 and 7. And then this is based off line. This is an implication introduction. This is not introduction. That was what was messing me up, actually. So this is a not elimination, not elimination, not elimination. So this is an introduction based off line 8 and line 1. So it's essentially the same thing. You could probably have stopped the video once I finished there, but I was just showing how it's essentially the same thing. It's just with more steps. So yeah, hopefully that helps.